In this example, the pivot itself has changed. So no longer do we have the pivot at a point B attached to a wall here. That's all gone. Now we have the pivot is about A, and that pivot is in the center of the beam. Now we'll compute things the same way. We just draw an arbitrary thin slice or thin rectangle. You can see that I've drawn one right here. And we compute d m sub a. Now, remember this is going to be plus or minus times the distance from the slice to the pivot times the force dx. So now to decide if it's plus or minus, think about a concentrated force in this one spot. Now, which way would the beam rotate? If we just had one concentrated force, none of these forces are here, just this one force and on this one little rectangle here, you could see that the beam would rotate in this direction. And we've decided that positive is this way. So this will be positive. Next we have our distance from the slice to the pivot. That distance, you can see the entire distance from the origin to the pivot is 5. The distance from the origin to the slice is x, so that means that this must be 5 take away x. In other words, you have 5 as the whole thing, right? Take away that x. So we have 5 minus x times our force, 6 minus 1/2 x dx. Now I want to show you the importance, before we actually compute the moment or do the integral, I want to show you the importance of the orientation, what we decide is positive, the positive direction. And this is really just a choice. We just decide that positive is counterclockwise. Let's say that we had, or when you go to draw your own arbitrary rectangle, let's say you draw it over here. And you don't draw it right there. Then let's see, d m sub a, so the distributed, or not distributed, the concentrated force on that small rectangle there. Now think about what happens to the beam if we just have that one force, just this one force right here. None of these forces are here, none of these forces are here. Now the beam will rotate in this direction. Notice that's opposite of our decided direction of positivity, right? So this would be a negative. So now let's compute the distance from the slice to the pivot. So now our x distance is this. That's x. And notice that this distance right here is 5. So the distance from the slice to the pivot, let me do that in green here. The distance from the slice to the pivot is what is in green. That distance is x take away 5. Now, notice that negative, distributing this negative through, right? This is actually 5 minus x. And so in fact, we do have the same thing. Now, if it wasn't for that decision of an orientation, what we decide which way rotating is positive, then we might not get the same thing there. We want to get the same thing. That's why we have this little blue arrow saying that's positive. So in either case, we get the same thing. And we can now compute the moment for the entire beam, m sub a, about a. This is the integral from 0 to 10, because we're going to integrate along the entire beam. The entire beam is 10 meters long. And I'll spare you the computations. I trust you can do those. The answer is 41.7 Newton meters.